Now let's look at our even degreed functions. So first we'll look at an even degree and a positive leading coefficient. So remember again that our positive leading coefficient means that our right arrow is going up. Leading coefficient always tells us about the right arrow only. The way we know which direction the left arrow is going is from our degree. When our degree is even, the arrows point the same direction. So this one is also going up on the left. I'm going to do a fourth degree function. And instead of looking like a right side up or upside down U, a fourth degree function looks more like kind of a sloppy W, I would call it. So it's going to look something like this, where it goes up and down a couple of times. But remember, our arrows on both the left and the right need to be pointing up. So that's just a random example of a fourth degree function, fourth degree polynomial. So now let's go ahead and talk about what's happening on the left and the right. So on the right hand side, we know that if we're on the right, then x is headed towards positive infinity. And for this particular function, f of x is also headed towards positive infinity because it's going up. So right is always positive infinity for x, but the y values or the f of x values depend on the criteria that we've just talked about. If we look on the left now, the left is always x headed towards negative infinity. Then f of x is headed towards, in this case, positive infinity again because our arrow is pointing up. So both arrows are pointing up. We have positive infinity for both. Finally, let's look at even and negative. Negative leading coefficient. Remember that negative means the right arrow is going down, specifically the right arrow, and then our even degree tells us that the left-hand arrow must be doing the same thing. So the left is there. And so I'm going to again draw a fourth degree function, but this one's going to be going the opposite direction. So instead of a sloppy W, it's going to look more like a sloppy M, I guess. Something like that. That's a little wobbly, but you kind of get the idea. All right, let's look at the right and the left. So on the right-hand side, x is always headed towards infinity. So as x approaches infinity, our f of x is approaching, well, negative infinity this time. Our arrow is headed down. And then on the left-hand side, we know that on the left-hand side, x is approaching negative infinity always. We need to determine what f of x is doing, and in this case, it's also headed towards negative infinity.